I would like to give better explanation about distance time graph by using the moving man PHET stimulation. So let me explain this animation. Here is the moving man. So this person can move left or right. Here you can see the scale 0 meter, 2 meter, 4 meter, 6, 8, 10 on right side. Similarly, on left side it is up to -2, -4, -6, -8, -10. It means if you operate this arrow mark up and down, so the man will move left to right. So we can change his position. And now you can see this square box. So this is the graph. So this you can take as y-axis position or distance in terms of meters, and horizontal this is the x-axis 0, 2, 4, 8, 6, 8 and so on up to 20 seconds. Now if I hit play button, it records something. Now here you can see a blue line is passing and white is just at here. Now the person is at 0 meter. Now if I move it up, now it is moving. Now again the person motion stop, again it is moving. Let me play back and let me explain in detail. Now the person is at rest, he is not moving. Now when the time is running at here, still the person is at rest. If the person is rest or object is at rest, we need to represent that as a straight line. Now still this time is running, the person do not move, so we need to represent that in distance time graph as a straight line. Now after 11 seconds, now the person started to move forward, so that's why distance time graph is increasing. And after 14 seconds, again he stopped. After reaching 3.14 meter, again he stopped. When he stopped, so we need to represent that as a straight line. So from here to there, the person is at rest. He is not moving. We need to represent his action, either movement or the stop, in the graph in the form of a line. So here this straight line, which is parallel to x-axis, represents the person is at rest. But when you come at here you can see now the person started to move. He is moving and he is moving forward. Now do you observe the shape of the curve at here? The shape of curve is increasing. Now after reaching at there, the person stopped. If the person stopped, again the line becomes flat, and up to above 18 seconds the person do not move at all, and again he started to move. Again the line starts to increases. Now in this one, so this straight line represents the object is at a rest up to here, from the 0 to now again it is running. Now still time is running, but the person is at rest. This action we need to represent in the graph, so we will represent that as a straight line on the x-axis itself. Now when he starts to move, now till he is at rest. Now he started to move. Now you observe the graph, how it is drawn and how it is increasing. I hope you got that. Again, now he stopped again. Now he stopped again. The graph representation becomes as flat, a line which is a parallel to x-axis or time axis. So this is the way to represent a distance time graph when object is moving. Let me show you one thing. Suppose what happens if the object moves back and forth. Let me take, so I can clear everything. So I kept objects, I kept my person, my moving man at a 0 meter, 0.03, yeah, make it 0. Now I will move. Now up to 2 seconds he is at rest. Now he is moving forward. Now at here again he stopped. Now I want to move it from back. Now he is moving back. So again I want to make it stop. Now he stopped. Again he is moving forward. Now he is moving forward. Now let us understand this graph. Now from 0 to 2 seconds, now here you can see time is running, but the person is at rest. Since he is at rest, how do we represent that? Yeah, it is just on the axis itself, because here it is the 0 is the distance. He do not move at all. Now when he started to move, you can observe how the graph curve changed. He is moving forward, so that's why the graph position is changing with respect to time. After reaching at here, he stopped again. So if he is at rest or is not moving, again the graph represents a straight line which is a parallel to time axis. Now this time he is moving backward. So when he is moving backward, now do you observe the graph is now falling down, because the position now changes. So that's why we have to draw that graph in the backwards. Now how far he came back? He came up to 0. Now that's why the graph went down. Again he stopped. When he stopped, the graph becomes straight line. Again it went up. When it goes move fast, when it is going up, the graph again moving upward directions. So this is the animated representation in terms of by using PHET stimulation, the moving man. I hope you got it. Plot distance versus time graph for the given table. So this is the NCERT, one of the problem. So let us draw distance versus time graph for a train. So this is the details. I got it from the table 8.4. Distances of stations B and C from A and time intervals and departure of a train. So according to given details, a train is moving to different stations. So we need to plot distance versus time graph. Let us see the graph at here. So on the y-axis, I have taken distance in terms of kilometers. On x-axis, I have taken time in terms of hours. See the time interval at here. So the 0 position, so 8, 8:15, 8:30, 8:45 and so on. So it's a 15 minutes time interval. Now on the y-axis, 0, 20, 40, so it means it's the 20 kilometers, 1 unit. We can call that on y-axis 1 unit equal to 20 kilometer. On x-axis 1 unit 1 unit equal to 15 minutes. That is the scale I have chosen it here. Now distance from A, just imagine train started at A. Now time of arrival 8 a.m., time of departure 8:50. So train reached already on the platform at 8 a.m. It's about to start, but it is departed at 8:15. It means it is already is there at station A from 8 o'clock to 8:15. So we need to represent that as a straight line. So time is started, but 8 to 8:15. So the train is at the station A. So at 8 it is arrived, and at 8:15 it is departures. So we need to represent that as a straight line since the train do not move at all from A station. Now 8:15 it is started to move and it reaches to the B station at 11:15. So B station is at 120 kilometers and it reached B station at 11:15. So this is my 11:15 and this is my corresponding point for the B station. For the B station, it reached at 11:15. So 8:15 it started from station A, it continued and it reached at station B at 11:15. In that meantime, it traveled 120 kilometers. Now, how do you represent that? So we will plot a line from here to there since it is moving forward. Yeah. Train reached station B at 11:15 and still remained up to 11:30. It means at station B, train halted 15 minutes from 11:15 to 11:30. So we represent that as a straight line which is parallel to time axis, not moving forward, not moving backward, just like stop. Now from 11:15 to 11:30, train halted means at rest. Now train departed at 11:30 and at 13 o'clock, it means at 1 o'clock, it reached to station C. So here for the scaling purpose, I cannot extend my graph, so I have taken a random point at here, but you draw with the proper scale in your graph. So I have taken 13:00 at here and train reached to 180 station C. So from 11:30 to reach 180 kilometers, it means at station C. Yeah. Now it reaches station C at 13 hours and it departed at 13:50. It means again it is at rest for 15 minutes. So from 13 hours to 13 hours 15 minutes, the train is at rest. So if you represent these as a points as a B, as C, now these flat lines, they represent rest. rest at station A, and this inclined line moving from A to B, and this line represents rest at station B, and this inclined line represents moving from B to C, and this flat line represents at rest at station C. So this is the way to represent the motion of an object in distance time graph.